Hi everybody. We're going to talk about trapezoids today. First I want to talk about a regular not a regular trapezoid, but a normal everyday trapezoid. A trapezoid has one pair of parallel sides. And that's about it. When you talk about a trapezoid, I'll draw one over here. I'll just draw one. You get two sides that are parallel like this. You get one side over here, one side over there. That side's parallel to that side. You get some funky diagonals going on here. That's going to be perpendicular to that side. That's the only thing you can really do, or not perpendicular. This angle is congruent to this angle right here. That's it. There's nothing special about the angles going on in here. Some other things you need to know: the sum of the interior angles is equal to 360 from the n minus 2 times 180 formula. It's 4 minus 2 times 180, which is equal to 2 times 180. Forgot to put the equal signs in, which is 360 degrees. So we have a 360 degree sum of all the interior angles. But for the normal trapezoid, that's all you get. Now, the interesting stuff happens when you get the isosceles trapezoid. Now, I didn't mention it here, but the parallel sides here, this is called the base, and this is called the base. That's a leg, and that's a leg. Didn't mention it there. I'll mention it here. For an isosceles trapezoid, what you have is you have a base here, that's base 1. You have a base here, base 2, and then you have two legs that are congruent to each other. So, if we're dealing with just the sides, you have base 1 and base 2. The bases are perpendicular. The legs are congruent. And if you really wanted to kind of see why, take a look. 1, 2, 3 boxes. 1, 2, 3 boxes. That's a right angle. 3 squared plus 3 squared is going to equal whatever that is. Over here, 1, 2, 3 boxes. This side's 1, 2, 3 boxes. Right angle. 3 squared plus 3 squared is what equal there. Same thing. So, when you're dealing with, and you know that they're isosceles, this is what you end up getting. So, that's just dealing with the sides. Now let's deal with the angles. Now the nice thing about this, if we were dealing with, let's say, if I continued this up, and we dealt with isosceles triangles, and I kind of missed it there, but kind of get the idea. It's not 100% right, but if we had continued and finished the isosceles trapezoid is really like an isosceles triangle with one side cut that's parallel to the other side. That's base 1, that's base 2, or base 1, base 2, whatever. It doesn't matter. Now, the cool thing is there are two base angles here. This angle is congruent to this angle. because this side, remember, is congruent to this side. Now, if we continued up, we still have an isosceles trapezoid, or isosceles triangle here, which means these two angles are congruent to each other. And they're supplementary to the same angles. These two angles have to be congruent to each other as well. So if you're dealing with these types of situations, you know your legs are congruent, your bases are parallel. And remember, also, think of this as a transversal. If that's a transversal, we have same side interior angles, which means this angle here and this angle here, if I add up these two angles, the sum is equal to 180. If I add up these two angles, the sum is 180 because this is still a transversal and these are same side interior angles. So there's a couple really cool things. You get two sets of base angles, just like if you had an isosceles triangle. Two sets of base angles because we have two bases. These two angles are congruent, these two angles are congruent. These two angles, the two base angles, the two different base angles added together is 180. Add those up, you get 180. If you don't believe me, you should believe me, say that's an X, that's a Y. That's an X, that's a Y. You get 2 X's plus 2 Y's is equal to 360. Divide everything by 2. X plus Y is equal to 180. X plus Y is equal to 180. So just a simple calculation proves that whatever these two are, they equal 180 degrees. You can pause here if you need to take some more time kind of copying this stuff down or seeing it, or you can rewind as needed. Now, mid-segments. Now, in order to find mid-segments, we want to find the mid-segments of the legs. Now, I drew these in a special way so I can find the mid-segment nice and easy is right here, and it's right here. So, we'll go ahead and I'll draw in this mid-segment, make it nice and blue so it sticks out. Now, let me ask you this. Will the mid-segment, since I know this line right here is parallel to this line, what can we say about the mid-segment as far as the parallel lines are concerned? Is this mid-segment ever going to intersect these two parallel lines? Give you a second to think about that. Alright, seconds up. No. This is actually parallel to the other sides as well, because since I drew this in a coordinate plane, I used the horizontal lines to draw my two bases, because remember, that's base 1, that's base 2, and this is my mid-segment, which connects the midpoint from here and the midpoint from here. So I know that side is congruent to that side's congruent to that side. Or, that's not true. That And because we don't know, they don't have to be equal. It just so happens, ladies and gentlemen, that I did this for an isosceles triangle and it works out the way that we want it to. But now I have the midsegment that's congruent to each other. This angle right here is congruent to this angle because they are corresponding angles. This angle is congruent to this angle because they're both base angles, but that angle is congruent to this angle because they're both base angles. This angle is congruent to this angle because they are corresponding angles. That angle is congruent to this angle because they're corresponding angles. So you get all sorts of wonderful corresponding angles here. Now, count up the length of the first base. 1, 2, 3, 4. The length is 4 units. This base, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This base is 12. The midsegment is 1, 2, 3, 4, 5, 6, 7, 8. I want you to try to figure out what the relationship is between the 4, the 8, and the 12. And if you were able to see that 4 plus 12 divided by 2, the average of the bases, base 1 plus base 2 over 2, that's 16 over 2, which is equal to 8. That's the length. Here, let me zoom out because we're running out of some spaces. Zoom the other out. That's your midsegment. Or you could have said from 4 to 8 is 12, or from 4 to 12 is 8. So I could have said 12 minus 4 is equal to 8. Then say, well, 8 divided by 2 is equal to 4. And I could have said 4 plus 4 then is equal to 8. That's my midsegment. So this midsegment's pretty cool because you get all these really cool congruent angles because the midsegment is parallel to the bases, and the midsegment is half the average of the bases. So to sum everything up, for the midsegment, it's parallel to the bases, and it's the length is the average of the bases. And you can figure that out any way that you really want to. So, if you need to pause and take a moment to write that stuff down, go ahead. Here, let me give you a moment. Alright. Now, last but not least, diagonals. Let me draw on this one diagonal. And it'd be nice if the diagonal actually drew itself. There's your diagonal. And let me draw on the second diagonal. Now, the only thing that really happens that's worthwhile diagonals are congruent. That's base 1. That's base 2. That side's parallel, or congruent to that side. If you dealt with this triangle right here, you would have got this angle. And that's congruent to this angle. So if you're dealing with this triangle right there, this triangle right there, and base 1 is a shared side, so you can say that the triangle ABC is congruent to triangle DBC, which then tells me, so therefore by corresponding parts, segment AC is congruent to segment BD. So those two diagonals are congruent. You could have figured out different, you could have figured out that side, that angle, and this side, where you could have had this angle there. So if you use triangle ABD and triangle DCA, you would have been able to prove that those two triangles are congruent and that the diagonals were congruent as well. So in order to prove that those diagonals are congruent, we have to prove that two triangles are congruent, and those two triangles just happen to have diagonals as one of the sides, and those are corresponding sides. So that's what you want to know about your diagonals, and that is really all you want to know about your trapezoids. So your homework is the property of trapezoids worksheet. I don't have it in front of me, but it's either 1 through 20 or 1 through 22. Just think all of them. And then do Thursday. Both worksheets. I will collect. Thank you, and have a great day, and make sure that you are nothing but nice to the substitute teacher. Thank you.